Houston, we have a problem.
This is the, just so you know, we're going to be talking about boats here real quick because planes, I think, can get up faster than we think. And also, I showed articles on my show the other day. There's already been articles that such and such plane has broke the sound barrier, because with the winds aloft, and that's just in the north, when the south is many times faster. But in the north, planes will catch that stream and they'll get places a lot faster and they'll break records. And then there ends up that their miles per hour was 950 or 970. But that's because they were going under the Mach and then Mach 1, and then they get the wind with them. So, but boats cannot really, as far as I know, aren't going to move a lot faster than we think, right? Like a cruise ship that goes 22 miles per hour is not going to bust out and do 40. You know, it's just, I don't think it's possible. So when you look at boats, let's start with this Antarctic Cup race, right? Which is what people always send me to. This is the cup race that they have once a year. They show the path of the races here. So basically they will race around this track. They don't go below the 60-degree marker. They race around this, and then there's a world record. And the current world record you'll see here is 102 days, 56 minutes, 50 seconds, okay? So remember that they sail the entire time. They don't take naps. They don't, you know, as far as like somebody will sleep, somebody will sail, but not, they're always moving. So at 102 days, we'll do a 102 times, let me get this up. We'll keep track here. So 102 times 24 hours equals 2448. That's the amount of hours that this thing was traveling. And it did a circumference of 16,000, where does it say the miles? I think it's 16,000 miles. I don't see right off here. It's a nonstop race around 14,000 nautical miles. I don't see it right. It should be about 16,000. Let's just say it's 16,000 and we'll come back. But 2448, so that's the hour. So we're going to go 16,000 divided by 2448. And we get 6.53 miles per hour, okay? So that's how fast he was averaging to get around 16,000 miles in 2,448 hours. Okay, great. Now let's look at what the circumpolar current is, okay? It's the biggest current in the world. It is the fastest moving current. Here you go. The Antarctic circumpolar current flows clockwise, okay, which is the way the race goes, which is the way people circumnavigate the world. You have a hard time doing it the other way. And when I say circumnavigate, I mean on the outside track, obviously. And it talks about it goes west to east around Antarctica. Anyway, when you look into it deeper, you can figure out that the average speed is about 2.5 miles per hour, sometimes 3. So we can now take that 6.53 miles per hour that we said the guy was averaging, and we can minus from that 2.5 because that's the current speed. So he's moving without even moving 2.5 miles per hour. Therefore, his boat is only actually going 4 miles per hour around the world. Okay, so now we find out who this guy is, and he races a, let's find his name here, I think. Yeah, he races his 85-foot open monohull trading boat. So I go search and find the fastest 85-foot monohull, and you find out that the boat goes 36 knots. That's 41 miles per hour. Wow. So a boat that goes 41 miles per hour has the world record for circumnavigating the ocean while traveling 4 miles per hour. Okay, so if you believe that, that's fine. But that's what happens when you're lying to people about distance. The guy probably got back, and if you asked him, for all he knows, he was going 4 miles per hour because he traveled 16,000 miles and it took him X amount of time. That's what speed is. Well,
he probably just divided the math, and he divided the time into the distance and said, right. Wow, I thought I was going a lot faster than that, but it only says 4 miles per hour.
Right. I'd love to talk because I bet you would say something like that. So, and then all of a sudden you realize there's not a lot of difference you have to do. So if instead we know that there's 2,448, well, let's say some people have said that the circumference is 60,000. I don't know. I don't know if things are that big down there, maybe 50,000, but let's just say 50,000. Just to see what speed would somebody have to go to complete that. And he's not all the way at the edge, remember? So the edge would be 50,000. He's not even past the 60 degree. He's just doing a circle at about the 60 degree mark. So let's say it's 50,000.
Yeah, they're usually in like the mid 50s.
Yeah, so
or thereabouts.
We'll go one more time and look at where was the boat? Here we go. So you'll see that they're not even getting, this is the 60 degree line here, this white line. And so they're staying above that. So right below Australia, they do have to duck down, obviously, in South America. Anyway, so it's not even the outer edge. So let's say it's 50,000. So we've got 50,000 divided by the 2,448 and that comes out to 20. So even at that, the boat's only going half the speed that it's capable of. That seems to make more sense to me than a boat that maxes out at 40, breaking a world record going 4. It's just ridiculous. It's like a car breaking the world record for the fastest trip around a track, and it actually goes 400 miles per hour, but it only went 4. What are you talking about? Why would it do that? Wouldn't somebody just come and break the record easily by going 8 miles per hour? Same thing is true with these boats.
Doubt.
Why isn't somebody breaking the 102-day record by going and, I don't know, putting your foot on the gas pedal at the boat? You might move a little faster than 4 miles per hour. And so that just tells me that this area here is much more vast, and nobody would ever know. It would be impossible for a sailor to know, because they're going to base everything off of known land distances. And those, when I say known, it's what GPS gives you. GPS gives you these answers. So when you figure out that, that boat fastest goes 41 miles per hour, and yet this guy's breaking the record going 4, it's that to me is a big problem. And then the other thing with the the boats are still, the planes are still falling off, and you're still getting an average or an estimate of their speed. Did you show that, Bob? Or I know you said you were going to get a, let me see here.
The advanced membership, I didn't show it yet, but because right now it's a guess. We've speculated for years what they could be, but supposedly I was surprised to see that with that advanced business membership, you get it all the way from 10 hectopascals all the way up to the top, all the way up to like 60,000 feet.
And it will give you its true.
That's what they say. That's what they say.
I did download the, what is it called? The CSV file that comes with it. But it didn't really tell me much. Just kind of said the same thing we already know. But I'm sharing my screen one more time. Sorry, I just wanted to check something. Share screen. Okay, back on. So this is the flight that we're talking about here. And I have the membership that allows you to play back flights. But one thing that, Wolfie said was that none of these planes fall off radar. Well, this is what these black dotted lines are, is when the plane falls off radar. So it does fall off radar. As soon as it gets away from the land, you'll see it just skips. It doesn't track it following those black lines, because it just skips and kind of goes along. And this is where it gets picked up. Who knows by what? I pointed out that those ABDS, is that what it is? ABDS?
Yeah, I can't remember what the acronym stands for, but I know what you're talking about.
Yeah, so they want to tell you that these are satellite tracked. Okay, great. But if you go to this website here, Flight Radar, they are giving away little devices that they want you to put at your house, and they want to cover the entire world with these little devices. Well, what do you need those for? If satellites are tracking the planes, and the planes then relay that, or the satellites relay that to ground stations, what does every house in America or in the world need a little ABDS receiver for? To me, it sounds like what you're doing is you're tracking planes by, I put a receiver above my house, and then you can track a plane when it crosses my house, or when it crosses the other way, or when it's going a certain speed above my house. And then you can just report that on these websites, and you don't need satellites. So
and it's even cheaper than launching balloons. So they're working it. They're working it.
Here's the other thing that I don't know if anybody's pointed out yet, and I'm still baffled by it. Okay, so let's watch the shadow here, right? So the shadow is the night. So we know that the sun basically would be here, right? The sun's going to be splitting these two shadows almost identically, right? So the sun's going to be here. And if you kind of watch the shadow, if the sun is moving on the outer track, or at all times, about 1,000 miles per hour around the Earth, then this plane surely cannot keep up with the sun, because the plane surely is not going 1,000 miles per hour. But if you watch this, and remember, this plane is flying, I know it looks like down on here on a globe, it means like, it's a great circle route, but it should fall behind the shadow. But watch as it goes, and watch as the shadow starts. So here it goes, and it's about 1, 2 in the middle of the third shadow. And as it goes, you'll see that it actually keeps up with the shadow. There it goes. You see it's just following along with the shadow, and ends up exactly where it was over here.
Oh,
which
that's crazy.
It's traveling 1,000 miles per hour. So
yeah, well, maybe the winds aloft are going that fast. Who knows?
Yeah, who knows? We wouldn't know, because they only report the one level, which is 32,000 feet, which usually goes west to east. But I know for a fact that they can put people at different flight levels, 1,000 feet above each other, and sometimes the 1,000 foot above another one will have the jet winds going the other way. So usually there's a 1,000 buffer zone that they call, I don't know, there's some move a plane has to do to kind of converge into the jet stream. So they leave that 1,000 for that. But there is definitely reports of 1,000 miles per hour plane, a plane going one direction, getting the jet stream behind it, and then 1,000 feet above that, or I guess it would be 2,000 above that, somebody going the opposite direction, getting a jet stream as well. So there's
Jeran, do you realize how big of a bust what you just covered up here is? Do you realize what you just did?
Yeah, I mean, I think it's big too. I mean, the sun.
It's huge.
Yeah, I think so too. I mean, I think it means that it's going 1,000 miles per hour. So if it's going 1,000 miles per hour and its distance was 9,000 miles, then, and it's, what was its supposed time of flight?
It was like 17 hours or something, 17 or 18 hours.
Yes, I mean, could it potentially be going 18,000 miles? I don't know. I don't know what direction it goes. I do think it has to catch the jet streams. I do know that the jet streams that go around the south are extremely fast. Also, they talk about how, and I don't know how high these winds go, but all of our winds get blocked by land features, right? Well, if you kind of think about the south, there is no land that blocks it at any point. So there's just a lot of, that's why the circumpolar current goes fastest. There's a lot of reasons. There's no impedance. It's kind of colder water. It's just kind of a setup for it to be, what you
need to do, Jeran, is you need to actually look at that footage and compare it on SunCalc and see if that is correct. Because if that's accurate, you have just busted it wide open.
Let me see if we can tell. I mean, it does look like it's going right from 3 to 3 right here. I mean, I guess you could say that if it gets here, that it's getting outrun maybe there. If you're talking about there, now it's not the third, it's the fourth. But I still think, and then we think that it's going, probably faster than 1,000 miles per hour on the outer edge. So that's what we need to figure out. And then I would love to see footage from this flight. So far, I've seen like one picture out the window. I don't know if anybody else has seen anything else. There's got to be somebody on there that's, I don't know, taking some sort of time lapse or some sort of video footage or something.
Well, I saw on your show that you had didn't you have some articles written about it, about how the flight was just completed, but they didn't have any pictures? Or was that somebody else I was looking at?
No, I think it was me, but I just didn't see anything that was, I mean, we saw like one tweet of a picture, which did seem to show Antarctica. But like you said, how do we know what these windows, that's just dumb. I can't picture, why would you ever need to take a photograph of what's outside and then display that for you inside? There's probably nothing dumber I've ever heard in my life. There's no bigger waste of money. It would be like, we're going to put cameras on the front of your vehicle, and then we're going to take that image and put it on your windshield so that when you're driving, you're actually looking at the camera view. What is the point of that? Why would you waste that much money? So there cannot be a reason for having screens looking out the window unless you're planning on fooling people. If you're planning on telling the truth, then just leave the windows alone. What's wrong with that?
Yeah, no doubt.
I can't really get that out. Anyway, there's just too much wrong with this, but this is what I really want to know is like true airspeed, indicated airspeed, and these things don't come up when you have the package I do. You have to have the level up. Then you can get these true airspeeds. Now, when I used to do this before, when it used to allow my level to have these, we would always see 1,200, 1,300 miles per hour down here easily on the flights from, I don't know what the number is of the Qantas flights that go Sydney to Santiago. Do you know your offhand what the name of the flight is? Sydney to Santiago. I just didn't know if you knew the. I don't think you can search that way.
I have no idea what it is.
I'll find it. Just we'll take a look. Maybe. Wait, what's this one? Here we go. This might be it. Here we go. Sydney, Santiago. I found you. So now this plane's going way. It's not going way down here like this one. This is usually where. So they're nowhere near Antarctica. But if you go to this one and we're going to go playback. Now you'll notice here too, same thing, right? This dotted line means that it's not on radar. It's off. It's not being tracked by, what's this? Sorry. It's not being tracked by anything. It's just kind of almost like an estimated position. Let me see why I probably need to turn off the other flights.
Yeah, I need to look up that system of identification, because it's like, why would this have that feature and no other flight does? And he was lying, the fact that it did disappear off radar. Of course, what do you expect?
Yeah, I mean,
it's Wolfie.
It doesn't disappear. I don't know if people. I don't think we've ever said it disappears like the plane goes out. And maybe it used to. I don't remember. I think it's always shown that dotted line, which is just saying that it's kind of estimated. And usually, this thing's a lot easier when you're not. Wait, let me find the name of the flight or the number. No, not Buenos Aires to Darwin. Hold on, let me find it. As soon as I get the number, then I can find the old flights and look at a replay of one of those. Here we go. So this is, it's LAN 1244. So LAN 1244. And then we're going to find that flight, this one. Okay, so now this is going to take us to the past. Should. Hide other aircraft. All right, that's better. And playback. So usually on these ones, I can get some older flights. All right, there we go. So these ones are, let's see, this one was October 6th, the last one. And how long did it take? Wait, flight time, Santiago to Lima. So they don't look like they have a past one more than 90 days. Have they? Oh, I guess because that flight's been shut down from Corona then, huh? Yeah, it must be it, because usually it's loaded all the past flights, but it's only saying that it only goes back 90 days. And I guess these are the only 2 flights in 90 days. There's other things I've talked about with cruises. You know, this distance here is supposedly 7,000 miles, which is from, here to here, 7,000. But if you look at cruises and do the math on cruise ships that go to Easter Island, then they go up here to Phuket, and they go to all these little islands, Samoa, and then they come down here. But by the time the boat gets about here, it's already gone, 6,500 miles. And it's just basically gone to Easter Island, to this island, to this side, this island, and you add up the amount of time traveled multiplied by 22, which is the fastest speed a cruise ship can go, and you get 6,500 or whatever I came up with on my show, 6,800. So that tells me that the distance is just a lot longer than they're telling us, not by a huge amount, but enough that they couldn't ever run undersea cables this way. Because if you told somebody, hey, we need undersea cables to run from New Zealand to South America, and they said, okay, what's the distance? Oh, it's 6,000 miles. And then they go run the cables, they're going to end up in the middle of the ocean about here saying, hey, how come we've just ran 6,000 miles worth of cable and we're not at the shore? So instead, they've made every single cable run from down here, up along Alaska, out to Hawaii, down the coast of the United States, down the coast, and just nothing goes across here. There's also no cables that go across here. There's also no cables that go across here. So all the cables are connected in the north, which makes sense. If you unfold this kind of map into a flat Earth map, it still would work with all the cables the way they're connected that were shown. So there's just too many things that tell me that something's wrong in the south. It's not just as simple as, oh, this plane does it and therefore everything's good, because all these guys do is believe everything that they're told, and they're so far gone that they think that you couldn't possibly lie. Like GPS can't lie. GPS only can be done to a globe, which is ridiculous. You could convince the people in the United States that they lived on a globe if you wanted to, and you could have a GPS system that would basically show that California and New York touched, and you could design it in a way that people would be very confused, that people would have no idea where they live. If that's what GPS would never lie to me. No, you can create GPS to say whatever you want it to say. I think it's the global positioning system. It takes where you are and places you where you'd be on the globe. So this is what happened with MH370, right? So the plane crashed out in the Southern Ocean. My guess is that it flew south and crashed somewhere over here, and it's in an area that's not mapped by GPS. So boats and stuff don't go through that area, and if they do, it's a quick, from here to here, and so they can't go and find that boat. That's my opinion of that one. So there's just too much wrong in the south, and until I see evidence of any kind, and I have somebody looking into that flight, just so everybody knows that they think they'll be able to at least get us a price and get the flight booked if we want. But they want to do, I guess it's Buenos Aires here to here, Perth, and going across the South Pole, supposedly, so that basically the entire time you're on the flight, you're looking out both windows, you can see the ice, and that flight, somebody's trying to get it booked for us, and then what we would have is I think it's supposed to fly in like November, December 2022. So again, a lot of people are like, I don't want to go on that flight, they'll kill us all. I say, kill me. I'll go on the flight, kill me.
Well, guess what, Jeran? I have my business account now open. Should we try this?
Yeah, okay, if you want to look at it.
That would be nice.
Very nice. So we'll see if anybody, and then we'll just offer it up, and if we don't make enough money, no big deal. And I already talked to him and said, well, if the airline or anybody else, the pilot or anybody like that cancels for any reason, everybody better get 100% of their money back. And he said, yeah, but you guys need to understand that if you pay for the flight or you book it, that you owe 25% even if you don't do the flight. I'm like, if it's our fault that we don't go, then yes, I can get that. But we would have time to earn, raise enough money to see it. And we would sell tickets. Basically, is all you'd be doing is we'd come up with the price per 2-pack, 4-pack, 6-pack, sell the tickets and see how many people we can get to join us on that flight and try and see if they can do it in the time that they say they can do it. Because I really do think I would want to see that Antarctica is on the outside of both windows without any sight of water, basically for over half the flight. because to me, if you're talking about on a flat Earth looking map, for them to get out over Antarctica, to fly around basically the entire outskirts, staying far enough inland on Antarctica that you can't see the water on either side, and then come all the way around and make it in 18 hours to Perth, or 17 hours, whatever they say they would do, I think there's no possible chance. And I would like to go on the flight, because if they can do that, then there's something up. Whether it's flying 1,300 miles per hour or something, I don't know. But I think that being on the plane and being able to be there, take pictures, use a compass, do all the things that we'd be able to do on that flight would be beneficial. But I don't think the flight will ever happen, obviously.
Yep. So I'm on it. As you can see, I now have the business thing, which supposedly gives us all of the flight level winds. The question is, how do I find it?
I'll help you, but will you? I don't see your screen.
Oh, shit. Okay. Let me share it. And let's see. Let me close these. I knew this would be a great idea. Okay.
Okay, there we go. So go, oh, you found it, QF14. All right. So now click play on the far right. Wait. Yeah, click play up top there. Buenos Aires to Darwin. In the gray box? No, not that one.
In the gray box.
Yeah, next to the little picture of a plane.
Oh, there we go. Okay.
And I want to see if it... So it's still not showing you any true airspeed, indicated airspeed. Let me see if it... Oh, GPS altitude. I don't think I get that one on mine.
250, 550. It's gone up. Track.
Where is its speed? Oh, ground speed. Okay. But it's still not showing anything on the... And you can kind of drag that along, Bob, just to see the plane. If you kind of grab it and drag it. No, the down below in the gray. The plane's path.
Okay. Gotcha.
Right. See if it ever shows. Oh, see, now it's showing true airspeeds and indicated airspeeds. Oh, and the ground speeds and knots. Do me a favor. Let's change it to miles. It's just easier to understand. Go to your settings bar over on the right.
Settings on the right.
Far right, the little cog.
Got it.
There. And then you should be able to, in miscellaneous maybe? Yeah, find aircraft speed and change it to miles.
Aircraft
Distance
speed,
in miles.
miles per hour.
And then vertical speed, feet per minute. Find wind speed. Change that to miles per hour.
Wind speed.
Where does it
miles
show
per
wind
hour.
speed? Something new.
Well,
And
this
then-
has every feature there is, so.
Altitude's already feet. Okay. 560. Where's it at? So 557. All right. Yeah, and then just kind of slow pull. I mean, it just barely took off there. So it looked like, from what I could figure out on its time, it averaged about 515
Oops.
miles per hour. Oh, see, and like that map is showing something different with the darkness.
This ground speed 49. I ain't believing this. They're gonna have to pick up some major speed.
Yeah, that's why, because I was thinking the same thing when they talked about it average 525. I was like, well, most of the time I watched it. See, that's just, see how it's like stuck at 512? That's why it tells me that I don't believe it. I think it's just, again, I try to describe it as, if imagine that all the planes in the sky are being flown by the computer, right? There's no human being that's in charge of like, this plane go right. You know, it's like a computer that adjusts everything, knows where people need to get and at what time. And this is why, if you've every time you're on a plane, you get on late, but you get where you're going on time. Why is that? Well, it's because planes make up distances in the air. They get in jet stream. The computer knows that. The computer knows this JetBlue plane needs to get to Dallas by this time. It's taking off 15 minutes late. Therefore, we need to put it up in this jet stream so it goes that speed and gets there on time. So the same thing could be true for the South, where the pilots wouldn't even know that the plane, if it had to speed up, if it even had to go past the sound barrier. Or, like I said, here's one thing that people never tell you, that as the temperature starts rising because of the stratosphere, that the stratosphere is so much lower at the poles, at both poles actually, and higher at the equator. So the lower that is, the quicker the transition from cold air back to warm air is when it gets to the stratosphere, then the mesospheres after that. But in the stratosphere, if you have it's lower, well, that temperature starts going back up, which is actually going to, and then there's less and less atmosphere, which I think is going to propel the plane even faster. I think the plane is made to go faster in less dense atmosphere, and that's what Bob's talking about with the redesign of the wings, the wing tips, the the wings kind of being shaped backward or backward, so that they kind of like some of the
they can get much closer to supersonic speeds, which is 200 miles an hour, more than 200 miles an hour than its rated cruise speed. That's a lot of playroom.
Plus, you have 250 mile per hour winds. So
exactly.
Even going 1,000 miles per hour is not out of the question.
Nope, I don't think so. So, Jeran, I just sent you my logon credentials for Flight Radar on text. Try it. See if you can log in. If you need a code, let me know, because they sent me a code, obviously, and I'll have to give you the code because I want you to play with this too. Yeah,
awesome. It's weird that it just got stuck though at like 555 and just stayed there, or whatever that ground speed was. It said it was going.
Yeah, true speed. This is horseshit. Oh, it's already done. Okay, no wonder. It's like, wait a minute, how'd that happen?
And I understand ground speed, and I understand true airspeed. Where's it getting that? It's basing it off of its pitot tubes and things.
Yeah.
And then indicated airspeed would be what the gauges are showing?
Actually, no, it's the other way around. It's the indicated airspeed is off the pitot tube, and the true airspeed, I forgot how that's actually calculated. It's been a while.
Okay, yeah, I know it's not the easiest. There's so many different descriptions of altitude even is weird when you're talking about a plane, because they talk about elevation and how they, some airports, the way that they're all measured from zero. It's just weird. Flying is weird to me. And what did we say? You wanted me to look up something?
I want you to see if you can get into it, first of all.
Oh, yes. I'll check that out. So then I was just also looking at the speed of sound table chart, because they say that at the ground, which is so weird to me, that sound travels faster in a medium, and the denser the medium, the faster it travels. So like in water, sound travels the fastest, right, as per air. Isn't that correct?
Yes.
Yeah, that's crazy to me. That just seems the opposite of what I would think it would be. And then I was trying to find this one thing, if I can find it. It's here somewhere.
So, and by the way, the calculation is true airspeed rule of thumb, and it's been a while since I got this. But anyway, for any altitude flown above 3,000 feet, add 3 knots per 1,000 foot to get your true airspeed. So basically, if you're at 5,000 feet, you add another 6 knots onto to get your true airspeed. So it's 3 knots per 1,000 feet.
So for 10,000 would be 30 knots. So if the plane's going 40,000
well,
feet.
10,000 would only be 7,000 above it, so it'd be 21 knots over that. So if you're 500, if you're doing 550, then it'd be 571.
And if you were up as high as 40,000, then you'd be adding 33.
33, yeah. The 37.
Okay.
So 37 times 3, yes.
And then I saw a lot of people asking about, does the Mach number change with altitude due to the speed of sound decreasing or increasing? And the reason you have to ask decreasing or increasing is they'll just tell you that the speed of sound decreases with altitude, but they never tell you that the temperature begins to invert at a certain height, in which case then going above that, the temperature starts to get warmer and you actually get that speed of sound starts dropping again. So I'm sorry, starts going up again. And it says here the speed of sound varies with the square root of the absolute temperature. Most aircraft cruise in the troposphere, the lowest layer of the atmosphere, which has a characteristic change in temperature between altitudes. Changing altitudes will result in a changing of local speed of sound. If you maintain a constant Mach number, you'll certainly change speed while climbing or descending, which is kind of what you and I were talking about, Bob, the other day.
Exactly. And so at 40,000 feet, you would add 111 knots onto your indicated airspeed.
Wow, I did not know that. So that's crazy. Okay.
I'm going to drop this into the inside chat here so you can see it.
I mean, the thing is that we are still be held to ground speed. And the problem with that is that,
and does that have to do with the thinning of the atmosphere at the higher altitudes? Is that why?
The reason for that, John, is because the pitot tube is basically the pitot tube is the tube that's in the front of the aircraft that actually takes the sample of the air pressure as it's rammed into it. And obviously, as you go as you go higher, it doesn't matter what level you go, the air gets thinner. Therefore, its ramming capacity, or its, it won't be able to press as hard on the pitot tube membrane to compress it as far. So they compensate for it by saying rule of thumb is three knots per 1,000 feet because the air gets thinner.
Understood.
That's why.
Right. Understood. Okay.